So let's pick our now favorite reaction, and that's methane with the hydroxyl radical, producing the methyl radical and water. So the convention for calculating the change in enthalpy for a reaction, which is distinct from the enthalpy of formation, is to take the sum of the product's enthalpies of formation for each one of the products, subtract off the sum of the enthalpies of formation for the reactants, and that's equal to the change in enthalpy for the overall reaction. So let's actually do this explicitly. So let's calculate the products first, and that means we want to calculate the enthalpy of formation under standard conditions of the methyl radical. Well, we can look these up in a table, and we see that the methyl radical has an enthalpy of formation of plus 146.7 kilojoules per mole of the methyl radical. Now we need to add to that the enthalpy of formation of water. When we look water up in the table, we see it has an enthalpy of formation equal to minus 285.8 kilojoules per mole. And we say, boy, that is an extremely large enthalpy of formation, and indeed it is, because it's sitting so far below that plane of the enthalpy of formation equal to 0, along with its companion CO2. So when we do that calculation, that gives us minus 139.1 kilojoules per mole. Okay, so now we've done the calculation for the products. Now we want to do exactly the same thing for the reactants. So in this case, we want to take the enthalpy of formation of methane under standard conditions. We look that up in the table. That's equal to minus 74.5 kilojoules per mole. We want to add to that the enthalpy of formation of the hydroxyl radical. When we look at that term, that's equal to 37.2 kilojoules per mole. And when we combine those two, that gives us minus 37.3 kilojoules per mole. All right, so now we've calculated the reactants, we've calculated the products, and we put that back into our definition of the change in enthalpy for the overall reaction. And that gives us the change in enthalpy for the overall reaction that's equal to the sum of the products minus the sum of the enthalpies of formation of the reactants. And so the sum of the enthalpies for the products was minus 139.1 kilojoules per mole, and then we subtract off the same quantity for the reactants. So we subtract off a minus 37.3 kilojoules per mole, and that gives us an overall change in enthalpy for the reaction of minus 101.8 kilojoules per mole. When we see that that's negative, that means that the reaction is giving off energy. It's giving off energy because the reaction coordinate looks like this, where we have methane reacting with the hydroxyl radical, producing the methyl radical plus water, and that delta H of the reaction is less than 0 because this reaction is exothermic. If, in fact, we calculated the change in enthalpy of the reaction and it was positive, then in that case it would be endothermic.